7.2, hypothesis testing for the mean when our population standard deviation is known. So this is going to be very similar to when we looked at confidence intervals and we separated between if we knew sigma and if we did not know sigma. It's going to again help us determine if we're looking at our normal distribution or our t-distribution table. So with hypothesis testing, we normally have two different methods that we can use to test hypotheses. That's our using p-values and using rejection regions. So these notes are going to be just looking at rejection regions and critical values. So this method is going to decide whether to reject the null hypothesis to determine whether the standardized test statistic falls within a range of values called the rejection region of the sampling distribution. A rejection region, or critical region, of the sampling distribution is the range of values for which the null hypothesis is not probable. If a standardized test statistic falls in this region, then we are going to reject the null hypothesis. I'm just going to abbreviate H sub 0. So critical value separates the rejection region from the non-rejection region. So if we want to find the critical value in the rejection region for a left-tailed test with alpha equaling 0.01, we're going to look at, going to switch over to table 5. Okay, and we want to look and see, okay, we're left-tailed, which means we only have one tail. And the nice thing is table 5, we have our different pictures for hypothesis testing. So when we are left-tailed with alpha equaling 0.01, and then we are going to go to the very bottom of our table because we're looking at our normal distribution, and we're looking at 2.326. But because it's left-tailed, let's slide back up, we have negative, so it's going to be a negative critical value. Okay, so if we switch back to our notes, I'm going to sketch this for us. Okay, so it tells us we have a left-tailed test. I'm going to shade this in. The shaded area is our rejection region. So this is where we will reject the null hypothesis. This unshaded region is where we're going to fail to reject the null hypothesis. And that critical value, z sub 0, is negative 2.326. Okay, and we got that from the infinity row of table 5. Okay, another way we can write rejection regions is as an inequality. So our rejection region is any z value, or z score, that is less than, because it's going to the left, of that critical value, negative 2.326. Okay. All right, if we want to find the critical value in the rejection region for a two-tailed test with alpha equaling 0.05. So again, I'm going to sketch the graph. Here, since it's two-tailed, we're going to shade both the left and the right. Okay, again, both shaded regions are where we reject the null hypothesis. And then we're going to go to our table. So again, going to table 5. And now we're going to look at the row that says two tails. And the alpha that was given to us, 0.05. And then going to that infinity row, and our critical value is 1.96. Now, if I jump over here and look at our table, or this little image, it shows us that we have a negative t-value and positive t-value. And so that's going to follow the same. So, jumping back to the notes, our critical values, z sub 0 is going to equal negative 1.96 and positive 1.96. Okay. If we want to write the rejection region, as an inequality, we're going to have z is less than negative 1.96 or z is greater than 1.96. That's going to represent both of our tails. So something to note, a standardized test statistic that falls in a rejection region is considered an unusual event. So remember, our decisions rule based on a rejection region is still the same. So to use a rejection region to conduct a hypothesis test, calculate the standardized test statistic z. If the standardized test statistics, so we can either reject the null hypothesis or we can fail to reject the null hypothesis. So remember, failing to reject the null hypothesis does not mean you've accepted the null hypothesis as true. It simply means that there's not enough evidence to reject the null hypothesis. Remember, if you want to support, we need to rewrite our claim so that it is part of the alternative hypothesis. All right, so our guidelines when we're going through and making hypothesis tests. So the first thing, similar to when we're looking at confidence intervals, is that we want to verify that sigma, the population standard deviation, is known. We also need to verify the central limit theorem, so that n is greater than or equal to 30, or the population is normally distributed. Okay. Step 2, we're going to state the claim, the null hypothesis, and the alternative hypothesis. We're going to identify the level of significance and this is going to be alpha. This will always be given to you within the problem. It's similar to looking at the percentage of confidence when we were making confidence intervals. Okay, once we know alpha, we can determine the critical value. Or values, ZC, and determine the rejection region. This is where I recommend you sketch the graph. Fifth step, we're going to find the standardized test statistic z equals x bar minus mu divided by sigma divided by the square root of n. We're going to make our decision, which remember is to either reject the null hypothesis or fail to reject the null hypothesis. And then seventh step, lastly, we're going to interpret the decision with context to the claim.